As you know, periodic table has metals, non-metals, metalloids, everything is there. So what do you think? What is in major percentage? Metals are maximum in number, then comes non-metals, and then comes metalloids. So overall, metals are close to 80%, then non-metals and metalloids are few in number. So where are they located? S block contains all metals, your D block contains all metals, F block contains all metals, and P block has few metals placed at the bottom. Alright, and metalloids all are present in your P block. Now, non-metals are all placed at the top in your P block. Carbon, nitrogen, phosphorus, oxygen, sulfur, right? Halogens, fluorine, chlorine, bromine, iodine, all these are non-metals. So, what are the properties? Metals have a tendency to lose electron and get oxidized. So, electronegativity of a metal is less, and non-metals have a tendency to gain electron. So, electronegativity of non-metals is very high. Alright, then if you go ahead and study, you will find there are uh, periodic trends in density, melting point, boiling point. As your atomic number increases, most of the time density do increase, and melting point, boiling point also have a particular trend. So which element in the periodic table has the highest density? Can you guess? So if you can't guess, let's see. So the element with the highest density is osmium among metals and carbon among non-metals. Alright. So next is in liquids, if you see, mercury is the element with highest density. Melting boiling points, melting boiling points, if we discuss in naturally occurring substance, the highest melting point belongs to diamond, which is a form of carbon or allotrope of carbon, you can say. So melting point for diamond is highest in naturally occurring substances. Next is tungsten has a very high melting point. So what do you think? Tungsten was earlier used in electric bulbs because of its property of high melting point. Among non-metals, if you see, so the highest melting point is of carbon, that is of 4000 Kelvin. The metals cesium, gallium and mercury are known in liquid state at a very low temperature, let's say 30 degrees Celsius. They will be found as liquids. Gallium is sometimes used in thermometers as your mercury. So at 30 degrees Celsius, gallium is a liquid. Alright. So these are the properties we have discussed over here. Some other chemical properties are like valency. Valency depends on which group the element is. Valency is decided by the electrons present in the outermost shell. As if we say for group 15, the number of electrons in the outermost shell are general configuration will be for group 15, the general configuration is ns2 and p3. So if all the electrons are lost, all electrons get, how many electrons are there? 2 plus 3. So total electrons are 5. If an atom loses, let's suppose n is there, it loses all 5 electrons, so it goes to n plus 5. Same way, if it loses 3 electrons, then the oxidation state is plus 3. You can call this as valency or oxidation state. The popular term these days is oxidation state, right? So you can call plus 5 oxidation state or plus 3 oxidation state. This is decided by their general configuration in the group. Alright, same way we can figure out what are the oxidation states of an element in a particular group. Alright, so this is it.